Hi everyone. In this video, we're going to explore the selection function blocks available in Alsmart Design. These function blocks are used whenever we need to limit values, select the highest or lowest value, or choose between multiple inputs. The selection folder contains 5 commonly used function blocks. Limit, max, min, MUX, SEL. You'll find these blocks in many HVAC, refrigeration, and industrial automation applications. They are especially useful when working with sensors, set points, analog signals, and operating modes. Let's look at each function block and see how it works. Let's begin with the limit function. The limit function is used to keep a value within a specified range. It has 3 inputs. In, the value to be limited, .min, the minimum allowed value, .mx, the maximum allowed value. The function returns the input value if it is already within the specified limits. If the input is greater than the maximum limit, the output becomes the maximum value. If the input is lower than the minimum limit, the output becomes the minimum value. Internally, the function works like this. Out equals the minimum of the maximum between in and min and mx. In other words, it first prevents the value from going below the minimum, then prevents it from exceeding the maximum. Next is the max function. The max function returns the largest value from 2 or more inputs. You can connect as many inputs as needed. The function simply compares all of them and returns the highest value. For example, -8, 120, -1000. The output is 120 because it is the largest number. A practical HVAC example would be monitoring multiple temperature sensors. Imagine 3 temperature sensors installed in different rooms. If we want to trigger an alarm based on the hottest room, we connect all 3 sensor values to a max function. The output always represents the highest temperature currently measured. Now let's look at the min function. Min works exactly like max, except it returns the smallest value. For example, -8, 120, -1000. The output becomes -1000, since it is the lowest value. This function is commonly used to detect the coldest temperature, the lowest pressure, or the minimum level among several sensors. For example, if several evaporator temperature sensors are installed, the min function can identify the coldest evaporator. Now let's explore the MUX, or multiplexer, function. A multiplexer allows the PLC to select one input from several available inputs. The MUX function has 2 main parts. First, there is the selection variable, called K. Then there are multiple input values such as I0, I1, I2, and so on. The value of K determines which input is sent to the output. For example, if K equals 0, the output is I0. If K equals 1, the output becomes I1. If K equals 2, the output becomes I2, and so on. Imagine we have 3 temperature sensors. Room 1, room 2, room 3. Instead of connecting each one separately, we can use a MUX block. By changing the value of K, we can choose which sensor is displayed on the HMI or used by the control program. This makes the program much cleaner and easier to maintain. The final function is SEL, which stands for selection. Unlike the MUX block, SEL only selects between 2 inputs. It has 3 inputs. G, a Boolean selection variable .in0, in1. The operation is very simple. If G is false, the output is in0. If G is true, the output is in1. Let's look at an example. Suppose we have 2 temperature set points. One is used during the day. The other is used at night. A Boolean variable called night mode controls which set point is active. If night mode is false, the controller uses the daytime set point. If night mode becomes true, the controller automatically switches to the nighttime set point. This is one of the most common uses of the SEL function in HVAC applications.